Okay, good afternoon or good evening, depending on their time zone. Welcome to the SCB Emerging Issues webinar. My name is Mark Schwartz. I'm the editor-in-chief of Conservation Science and Practice. And today it's my pleasure to be introducing Cortni Borgerson, who is the lead author on a paper that has just come out in Conservation Science and Practice called Nutrient-Rich Traditional Insect for Improving Food Security and Reducing Biodiversity Loss in Madagascar and Sub-Saharan Africa. Cortni is an assistant professor at Montclair State University and is coming to us today from New Jersey. So the protocols for the seminar is leave yourself muted, please. If you have a question, like a clarifying question along the way, go ahead and type it into the chat box. That would be great. And we will open up questions at the end for everyone to follow up on issues that come up as we listen to the seminar today. And then I'll close it out by saying something about next week's seminar. But with that, let's go ahead and hand it over to Cortni.
Hi, I'm really excited to talk to you guys today about this project, and it gives me an opportunity to speak on behalf actually of a lot of people who are involved in this, including two incredible entomologists who were my co-authors, and Brian Fisher and Matthew Ardema here, and on behalf of the team as well in Madagascar who are out here in the rain, I hear today counting bugs. So I wanted to make sure, even though acknowledgements come at the end, that I am one face in a great big team. So today I'm super excited to talk to you about this paper that is on one specific nutrient-rich traditional insect, which I will call sakundri, which is actually the local Malagasy word for Zana tenebrosa, the insect species that we're working with there, and about our efforts there to farm the insect to reduce biodiversity loss and improve food security in Madagascar and potentially beyond. So I wanted to start, I guess, first with a story, which we can't do in the papers themselves, on why on earth we ended up even working on this project to farm a little insect from the forest in Madagascar in the first place. About a decade ago, I was in Madagascar waiting for food to be served and did what I think all of us do when we're kind of wandering around a kitchen outside, which is start to peek around at the bugs. And I found this little insect. These are the photos that we took that day of a bug that I had never seen before that was on a bean plant wrapped around a banana tree behind the kitchen. And I was really excited because it just looked extremely cool. And I called over the two people that were outside with me at the time, one which was our parabotanist, who I was like, okay, you've seen a lot of plants, you've probably seen this bug. The other was a 14-year-old neighbor kid who now works with us on our team a decade later. And I asked them, what is this insect? And they said, delicious was what the child said immediately, which was not what I was expecting at all. And we actually fried up the insects that were there, and I learned that they were right. I thought I was eating my first insect, and these guys taste like little lardonnettes or little pieces of bacon. They're delicious. But actually during this meal, I learned that I'd been eating insects for the whole prior year and a half that I had been at this particular house and just had no idea. So it might have been the first bug on a long insect journey. And what I was doing at the time there had nothing to do with insects at all. I was actually studying the hunting of Madagascar's primates, of which 98% are threatened with extinction. And because of that, I was really looking at how issues of biodiversity and food security were handled in Madagascar and by different efforts. And most of the efforts that worked to address these at the time tend to be separate things. They were either working on biodiversity issues or on food security issues in these two different worlds. But I already knew that they were connected. So instead of trying to look at the problem that we were facing with the hunting itself as something where either we were going to reduce biodiversity in order to improve food security in the region by using those resources, or where if we were going to improve biodiversity, we had to cut off food security, what I wanted to know is if we could use these insects and other tools that actually recognize this interconnected system between the forests and the people. Because we knew in the area that we did not only have really high food insecurity, which we did. 78% of households within the northeastern Madagascar where this took place, which is home to Madagascar's largest national park, are food insecure. Over half of all money in that household is used to buy food, and most of that actually goes to buy micronutrient-rich foods, which sit on top of your food. Because of this, biodiversity is high and child malnutrition is also quite high. In fact, the micronutrient deficiencies in the region have led to rates of stunting that are some of the highest in the world, including about half of kids. And these are particularly high in households that depend on forest resources for food. So, and a lot of the homes that are actually depending on these natural resources, most of the children are in fact stunted. And this is because in Madagascar, the hunting of forest animals is primarily driven by food insecurity, which is not the case everywhere in the world. And here, much of the nutrition that these kids are getting are actually coming from these forest animals that they're eating. So about a third to a half of all of the animal-rich sources of protein, iron, and kilocalories that people are eating in this region are actually coming from forest foods. So we knew that these two were connected. But what I wanted to know was, could I use this interconnected forest and food system to actually find ways to develop culturally relevant local solutions where people could obtain a sustainable, safe source of forest food outside of the protected area itself? Could we use this kind of interaction, and instead of trying to treat them as separate issues, which could be counterproductive because it ignored the roles that forests were playing, we could kind of monopolize and really kind of build upon the fact that the forests and the agricultural systems were not as distinct as we once had thought. Which brought me back to this bug. And it is a bug that I was really excited about for a long time, but that hadn't been studied. So the first thing we did, of course, after we got excited by the bug in the first place, is we started doing a little bit of pilot farming. We looked into literature, and unfortunately, we couldn't find out anything about the insect at all. It had been named in the 1950s. It was in some museum specimens around the world. No one could tell me the host plants, the reproduction, how long, nothing was known on this. We didn't even know what the eggs looked like. But what we did know is that insects were a really important source of food worldwide, right? 2 billion people eat insects regularly. There are over 150 different countries where insect eating is regular, and that includes 2,000 different insect species. One of these countries is Madagascar. And here, there was a bug that excited us, and it was this insect, Secundria urzana tenebrosa. It's a fulgorid plant hopper. It's in the hemipteran group, for if there's any entomologists out there. And I was excited by the potential of this particular insect because, unlike other insects that I knew of that had been farmed, it did not appear to actually require a high quality feed. It could be grown open air on bean plants that were already frequently grown in the region. It didn't seem to colonize or feed on any other types of agricultural crops. And because it just had this system where it didn't have this high investment, from what we could see, it made it a very exciting potential solution for remote regions where communities are living with forests, but that have extremely low infrastructure that prevents a lot of the other type of food insecurity projects that I've worked on in the past to have been deployed at that scale and long term, and makes it really difficult for a lot of hardworking NGOs to actually get out to these regions in the first place and continue to monitor them. But we didn't know if it was feasible. So this project became part of this piece of exploring this insect that was traditionally eaten to see whether it could play a role in biodiversity loss and food security in Madagascar. The first thing we needed to figure out whether it was even feasible. Could we even farm it? And particularly, was it feasible with very low investment in forest adjacent communities that had low connectivity and low infrastructure, which is where most of the places that really need this in Madagascar lay. In order to figure this out, we actually distributed the beanstalk for the plants that we were aware of as host plants and trained the households on everything we knew for farming. Of this, we did this in 5 different communities were involved in the project, 3 of which we trained, 2 of which remained as control sites to those. For the households that we actually shared the seed stalks and trained, 93% of them planted the beans that we gave out in underutilized lands that were nearby. So these were along fence lines or in between existing crops. 81% of those plants reached maturity, and that gave us a population of about 4,414 different host plants to watch these bugs on. And the nice thing about Secundria is if you plant their host plant, they will arrive on their own. So we didn't have to move eggs or insects to the plants themselves. We planted the host spot. The insects arrived on their own to the host plants once they reached a little over 1 meter high, and they established a population that could then be maintained by that plot's owner. And to see whether this actually worked, every 2 weeks we went out and we measured the growth of each and every one of these 4,000 plants. And we looked at the population size and structure of the bugs on every plant as well. And then went back to the individuals that own that plant and discussed with them about how many beans and insects they had harvested in addition to what we could physically count. So most of these plots are not intensified agricultural plots. People planted them where they wanted them to be planted. So for example, this is a little sandy area where we actually used a wild bean that could grow in places where food crops normally cannot grow. It's planted along a fence line next to a soccer field. This particular plant that they're being planted on is known to also prevent erosion. And the soccer team planted it there so that they could harvest and eat secondary after a game and celebration. So when it came to farming, we got a lot of bugs really, really quick. Our populations within the communities where we work for the colonies themselves were about 90,000 insects as a maintained population in addition to what was harvested. So this happened within the very first year of the project and is currently our averages right now are about 93, about 4 years later. So each of the different plants had about 65 bugs in addition to what was being eaten by that household. And this was working very well with the farming, but when you're thinking about a conservation strategy, you don't necessarily know that farming it is going to be enough, right? So we knew that we could rapidly increase the insect population size itself. The other piece of this is, will people eat them once they are there? What role does this food play within local culture? Because if we're trying to change dietary patterns, just swapping out a 4-legged animal for a 6-legged animal isn't going to work unless it fills the same type of cultural roles that are there. And then also, what were the effects of this project on the people themselves when it came to their food security, their nutrition, which means that we needed to figure out the nutritional qualities of the insect itself. And then I wanted to give you guys a sneak peek at the feed conversion ratios as well, because we've been working on this for another piece. And, are you getting more food out than you're putting into the system? So we did, depending on the frequency of the behavior we're looking at, we did weekly, monthly, and annual surveys of a little over 1,000 individuals, looking at their food security, their health and nutrition indicators, as well as their food consumption and production strategies. We did consumer taste tests of secondary along with a bunch of other bugs. And we also did nutritional, microbial, and antimicrobial analysis. And what we found with secondary is that overall, the first thing we did is figure out, is this a bug that people want to farm and what is the role before we even went forward with farming? And 60% of the people that we talked to described it as rich or delicious, 52% as a food that they really liked, 3% is healthy, and 6% kept coming back to this fact that you didn't even need oil to cook such a fatty food. It just produced it on its own, this magic that was there. So 100% of everyone we interviewed used this very positive language to describe the insect as a whole. And in fact, among bugs, it was ranked the #1 wild and or farmed insect that we were surveying in the region. With this, it's exciting that these insects, along with all other insects and forest mammals, have a national identity. So this is actually serving to meet a lot of these national identity requirements of foods that, of course, we all have within the region, whereas many other livestock, while seen as delicious and fantastic, were considered a foreign food. Fadi, or a traditional food prohibition that exists in Madagascar that's inherited. We knew that it exists for the insect, but we found that it's within about 1 to 2% in each community, which is quite good because that would prevent individuals from wanting to farm it. And overall, people saw it as a very clean food because the insect is actually raised above the ground. It means that it's separated from any of the waste product. So it's seen as a particularly cleanly food. It's a non-gendered food that could be eaten for breakfast, lunch, dinner, or snack, and did not have any association that would have limited its consumption to like breakfast foods, for example. In addition to being edible at any time, we found that it was actually quite nutrient rich, which is very common for many different insect species. It's high in a lot of macronutrients that are really lacking in the region, particularly in fats and calories that people have a hard time getting enough of on a frequent enough basis. Micronutrient content was also extremely high, not only for things like zinc and iron that are key for child growth, but also for things that are really lacking in small amounts like calcium as well. When you think about how this compares to other meats, right, that are on the table there, the nice thing is that it's not only exceeds the values for many of these products to beef and chicken, which we might be more familiar with, but it also comes in smaller packages, right? So many of these types of nutrients that you have to eat quite often that mean that when you're in a place where you can't just buy kilos of meat, instead of having to kill your entire chicken, right, and eat that within the spoilage period, you could actually eat these more frequently to increase the nutritional status of your household. These bugs actually store extremely well. Shelf stability lasted for about 2 months with relatively, bi-weekly to weekly retoasting of the insect itself, which in a tropical hot rainforest was extremely impressive without gaining any type of microbial content during that time. And in fact, we found the antimicrobial activity for things like for Streptococcus was actually significant as well, which may explain some of its stability. With all these good things, people ate them a lot more. So in addition to the farming before the project themselves, we found that households on average ate about 11 insects per household. In our control communities, this stayed the same, which is exactly what you would expect. But in our intervention communities, 1 year post-intervention, the average insect consumption in each household went up to over 3,000 bugs. And there was a wide standard deviation here that went as much as 25,000 insects in particular households. The reason I mentioned that is for future work that we're doing right now, looking at the impact on hunters, the top consumers, these ones that are eating 24,000, 20,000 insects per year, are some of our most food insecure households that truly do rely quite heavily on forest resources. This resulted in a significant change in dietary diversity. Our weekly means for dietary diversity indices, 23% of our households were able to move from low to medium because of the ability to eat these insects in very small proportions and to fill a gap that was really missing within the diet. This was achieved with really low investment. Households spent less than a cent per year on the project. They didn't require any new space to be able to plant it because of the growing patterns of beans, which are lovely and infuriating, which I'll get to in a second as well. Very low labor as well, just the harvesting labor and the amount of labor to plant the bean in the first place. And this gave a market value return of just shy of $70 and the product consumed, which is also sold in the region for an average of 7,000 Malagasy hari per kapuaka, which is a standard unit, somewhat like a cup. In addition to this, we've been looking at the FCRs more recently because when you're thinking of food security, the fact that we're feeding them part of a bean, even though they're phloem feeding insects, so they're eating the phloem inside that plant as opposed to the product itself, I wanted to make sure that we were getting more nutrients out of these bugs than we were putting into them from the edible product. So when you take the edible product that's being fed, quote unquote, which is the Lawson bean, I'll speak about in a moment to them, we actually found that compared to other types of meat, which do lose some of the calories and protein that you're actually feeding them, that you could be getting by eating that grain, that still was about 3 to 15 times higher in their feed conversion ratio than other beef, pork, chicken, and even salmon, which was quite exciting. And in fact, what was really exciting that we're looking at now is they appear to actually bioamplify things like iron, zinc, and fat, which means that you're actually getting 2 to 16 times the amount of those nutrients than you're putting into it from the edible portion. But because this has been studied too much in insects, we don't know if this is really common among all insects, which it very well could be, or if this is unique to phloem feeding insects, which given their biology might make a lot of sense. At the end of the project, people were really happy with it. We hired an external survey member who is not a part of the team to come through and do a separate analysis. That way they didn't know they were involved with us. 83% of the households were very happy with the farming project. 17% were happy. 0% were not happy or just like, I don't know, Participants overall that were involved in the project, 99% of respondents wanted to eat even more secundary than they were doing, which meant we definitely hadn't reached the top ceiling of the demand for production in the area. And then in the communities surrounding the ones in which we worked, 96% of households had heard of the project and wanted to be a part of expansion should it have actually gone to them within their regions. The biodiversity and host plant impacts beyond the human impacts were quite exciting. In order to actually measure this, we did enclosures and exclosures of the bugs because we couldn't just use the plants themselves, that we put 50 insects to breed happily in the enclosures, and then we excluded them from other colonies as well. And then we took daily measurements of the production of that plant. And we also looked at habitat change in forest plots to make sure that we weren't actually getting these nutritional successes at the loss of habitat from clearing for planting 4,000 additional plants within the same ecosystem. We found that the project did not increase habitat loss at all. It insignificantly reduced it between the two sites. So we had no additional habitat that had been cleared for the plants that were being planted to grow the secondary on. And in addition to this, there wasn't a lot of impact on the host plant, which is fantastic because this means that we can actually co-crop the insect, and the host plant itself. So when you're farming these, you're not only getting a traditional source of meat, you're also getting beans, which is a lovely shelf-stable crop as well. So it had no significant effect on the number of pods that were produced per plant. It did have a significant effect on the weight of each individual bean. It was about 10% lighter, but still, given the amount of meat that came back, this was a net gain for our farmers. With this really exciting news, I was delighted for the mashwala. But what I needed to look at is this something that just makes the mashwala region happy? Is this something that could then be applied across Madagascar? What is the potential impact of this? Or is this exciting project we did really only good for us out here on the Northeast? In this case, what we did is we looked at the overlap of the known presence of the insect, both by reviewing the literature and looking at museum specimens around the world. We took that and we overlapped it with places that were likely to have high natural resource use, which is the target community for this project. Those are places that were particularly food insecure and then also high biodiversity. So that way we knew that they both had the need and the ability of the biodiversity to rely on, in that case, for food. And then we've also been working on, since this, and I'll give you a little bit of information on a couple of different pilots and collaboration projects now to see if the same results that we found here can actually be replicated, and if so, how far. The known range of the insect was really wide. This was actually quite delighted. It covers most of sub-Saharan Africa and includes some of the most biodiverse and least food secure nations in Africa. This is the range that's all the way across. There's likely a lot of places where work has not been done that we're going to fill in. And in fact, there's unpublished iNaturalist and other photographic evidence, as well as talking with partners across much of sub-Saharan Africa region that we're going to fill in. These are places that are particularly food insecure. They're also places that are particularly biodiverse, where the ability to rely on this biodiversity in a sustainable and positive way to improve food security would be particularly needed. So when you overlap these qualities across the range, Madagascar, DRC, the Republic of Congo, Togo, there are many countries throughout this range that are some of the most biodiverse and least food secure regions in the world that overlap with the range of this particular insect, which makes it quite exciting. Across Madagascar as well, we've run 9 different pilots now to assess the feasibility in other sites, all of which have been good. And we're working with 3 different NGOs at the moment who are currently replicating the results, and everywhere from the south of Madagascar all the way up into the north. And we're expanding the results using these training manuals, which share everything that is in this manuscript and a couple of others with the communities themselves, so that they can then farm this as well. Because literacy rates are low, we use playing cards, but it's basically kings and queens to tell the sexes apart. What is the nutrient content of the bug? How do you cook it? How do you prep it? And a lot of this actually builds on some of the terminology, like eighth will show the enemies because it means faval. It's the eighth in the translation itself. So we're working with numerology with these as well. And what I found mostly exciting about this is not just that this project worked so well, that we were extremely lucky and was such a delight to be a part of, but that by really recognizing this interconnectedness between forests and food security, we might be able to work in ways that actually improve the conservation of biodiversity and food security at the same time, without excluding communities from a resource to which they hold traditionally quite valuable. So, like I said, this is part of a huge group of people that I truly cannot have done this without. So I want to really acknowledge those who were not here today, who played such an important role in this. I also want to acknowledge my family, who has eaten a lot of bugs over the last few years and should get all of the credit they deserve for that. And the incredible sponsors who took a chance on someone writing out them, particularly National Geographic and the IUCN SOS Lemurs project, saying, hey, let me farm this bug you've never heard of and see if it works out, because we've had a lot of success in our village, and it's really thanks to them and their commitment. Now I'm really excited mostly for the questions, because there's a lot of work that's been done, but there's so much more to do. So I'd love to know if anybody has any questions.
Okay, great. Courtney, that was great. Thanks. It's really nice to hear, gosh, a positive conservation story. That was really, really fun. So we're opening up for questions. So you can go ahead and throw a question into the chat if you want, or just unmute yourself and turn your camera on and ask the question. But I'm going to start with a question. You said something early on that struck me. You were noting some percentages of people's viewpoints on the food item, the bug, and you said 3% of people viewed it as healthy. And I thought, if everyone thinks it's good and everyone thinks it comes from the natural environment, I would think most people would think it's healthy. Do you have any reason why to think that such a low fraction of people think it's healthy?
Where the project is built, this has been a really key area of future development that we're working on as well. Those were done before we had done the nutrient analysis. So it was something that really wasn't thought too much of because it was found in such low quantity. So it was like, yeah, I love this food. It's fantastic. But I'm not eating it that often. And I don't really know, is it healthy for me or not, right? That hadn't really had that piece of consideration that's there. It is probably one of the things that people find most surprising as well. And I don't know if it's that so much of the conversation around what we eat is around what we should avoid, but people, as we've expanded the project, are so excited to see that a food that they already know of, that they identify as something that they used to eat with their grandparents or parents, or in the rural areas where they're from, is actually one that was so high in nutrient content, since it hadn't been done. And that analysis was done at the National Laboratory. So that was lovely.
Yeah. Yeah, also, we're looking at this adult emerge out, and I think of insect outbreaks. This is a very cool video, by the way. What's their host plant specificity? So you get people to start growing these things, and maybe they're not a pest on the beans, but can they be a pest on something else?
This was one of our primary concerns early on is, one, why aren't people growing it in the first place, right? So there's a lot of issues with growing the host plant that we're still working out in the region. Beans are somewhat complicated. But two, are they going to stay on it or not? And how wide is that? So even at colonies of 200 to 300 insects, 300,000 insects in a very small village site, we've never seen them feed from anything other than the leguminous host plants or even rest upon on which we're farming them here. So these are mostly within Vigna. There's some Facilis donatus. There's the lima beans as well as many other commonly grown beans that they will feed from and rest on. There are some wild Vigna as well, like Vigna marina, which is a beach bean that is quite common throughout much of the world's coastal regions. But we have not seen it on anything other crop wise, including when you get extremely dense insect populations that are co-cropped with other food crops. We've never seen it on any of the other crops that are there. So they seem to be relatively specific with their host plants, but also somewhat flexible among different bean plants within that genus, which for our purpose is fantastic because it meant that as we're looking across Madagascar, there are places where there are other types of species of bean that do better to other climates. Or that are better for habitat restoration projects that we can do it on. But if it's not a bean, they don't care. So that's quite lovely.
Yeah. So this was just sort of a right-hand turn for you in that thinking about what you were studying and then turning to this. Are you continuing to pursue this as a research project? I mean, I'm kind of, as you were talking, I was envisioning a Shark Tank presentation with secondary burgers.
Which we have made and is delicious, but no. So, I mean, most of my work is focusing on the unsustainable use of natural resources, right? Yeah. And the role that plays within food security. This project came out of our effort to come up with solutions and quantitatively measure different solutions for that. So we're collaborating on poultry projects out of Mahari, right? This one with the insects that are there. So what we're doing right now is still looking at the use of natural resources in the food security within these local communities, including rates of lemur hunting over time. But how do we actually design projects where we can find foods that fill the same cultural roles, meet the same nutritional pieces there, and can reduce things like primate hunting and habitat loss while improving biodiversity? So those projects are still going on. And right now we found that this is one fantastic opportunity for communities to do just that. So as we continue to look at hunting and other things around, we're also training people how to farm sequendry as we go. And it's a nice way to give something back to the communities that give us so much when it comes to data.
Yeah, it's a great, hopeful story. Do you worry about, I mean, is there a risk of too much success? So
that'd be great.
Well, I mean, farming All takes resources, right? And so if all
Yes.
of a sudden you convince these people and were successful at finding an export market on
Yeah.
Sakana burgers, then you could potentially drive deforestation with
Yeah.
this, right? Right. And so, but yeah, I know you're a long way away from that. But what do you do in thinking about this problem?
That was always one of my concerns, because just because you add an additional food to the market doesn't mean you're not just going to monopolize that and, right, clear additional resources as well. This is something that we see with things like mopane in mainland Africa, right, where you can start to drive and pull it out of the ecosystem as well. So currently, right, we've seen that, because we're not farming them into the wild forest side, right, but we're kind of creating this other nether region, it doesn't seem to be affecting the wild populations. The other side of this is we don't know where they're at in the forest, right? So we're looking at this that's there, but currently the information doesn't exist to go and continue to extract them out from those sides. We need to figure this out. It's part of what we're trying to do right now, in fact, is to really understand the wild ecology of this insect as well. And then the fact that with beans, where they go and where we're working particularly remotely, the individuals there are looking for an extreme low investment opportunity to improve their food security as opposed to a high investment. We're going to have to watch it long term. If bean farmers themselves start monopolizing on this and there became suddenly a huge external market, we'd have to keep an eye out. But hopefully somewhere along the way, it would improve food security in a way that would reduce biodiversity loss and others.
Right. So this is the point where I should pause and give other people a chance, because I'll just keep asking questions.
Oh, that's great too,
But yes, but I want to get everybody a chance to ask questions if you have a question for Courtney. Okay, I think I did that. So I was told once that you should count to 7 when asked, waiting for people to. I counted a little quickly there, but counted to 7. So I'll ask another question. So this sounds like the kind of story that the press might pick up on and be really enthusiastic about. I mean, we all like solutions, and
Yeah.
this is the kind of thing that sounds like the win-win kind of conservation story. Have you had press reaction to the paper, and what is it?
Yeah, I've actually been very shocked and amazed by the press outreach that we've had. Time Magazine did a piece on Brian Fisher's work with crickets that included this work here as well. There's been a lot of people that are quite excited. There's of course the tendency to push it even farther, right? Like, this is the solution to
Right.
all, right? And of course it's not, but it's been really nice to see a project that's felt really good to work on, that's really been a collaborative effort with the communities themselves within these regions, get a lot of good press because of the kind of integration of, the biodiversity loss that is driving a lot of the work that we do in Madagascar, but also with new biodiversity and using that in unique ways and depending on new types of food sources that aren't actually new in many of the places where we work. So that has been a fantastic experience, but at the same time, an excellent reminder to really talk about, this is one piece, and while we've seen fantastic results, it's a way to further diversify food systems as opposed to, the end all be all solution to all time. Not that I mind positive results, because it feels really, really good, but it's always good to keep our heads on too.
You had an offhand comment early on about you'd been eating insects for the better part of a year.
Yeah.
So are there other opportunities and options? What insects were you eating, and how were they collected?
There are a lot of wild insects in Madagascar that are traditionally eaten. And in fact, when we started this project, we looked at the feasibility of most of them. So for example, the insect that I had been eating is actually a dragonfly larva, which is sifted out with shrimp. So I thought I was eating shrimp, which I was, about half of it from the rice fields themselves. There are also multiple types of larval stages of different beetles that are eaten through the region. There are other insects that are very commonly used in insect consumption, like crickets and other species as well. So we looked at the ones that were there. Some were particularly difficult to figure out how to farm, things like cicada and some of the larval stages of beetles, which take 2 years in the reproductive cycle. Others were not particularly well liked, right, in the region, or they filled cultural roles that weren't those that we were looking to actually maximize with it. Either you eat very rarely or during very specific scenarios, not something that would have a large effect on food security, or they weren't seen as a local native wild food, which means that they could work great for addressing urban food security in places where we might be able to use a high investment type of farming. But if it's not native in the region, can establish itself pretty easily, then it might not be the appropriate source for this context, which is very, very rural forest adjacent. But it does mean that I got a chance to try a lot of different bugs over the past few years and discover that insects are very different. And really considering food's use and the reason why we're choosing a food in any type of meat project is extremely important. So it's not just bugs or not, it's do you want bugs that are like shrimp, or bugs that are seen as fallback foods, or bugs that are seen as, storage foods, or ones in this case that really serve the cultural role as meat, which for us was perfect.
Yeah. So harvesting a product is often a costly thing. And you mentioned getting some dragonfly larvae incidentally while people were pulling out shrimp. That's one way to harvest that thing, but I presume you're intentionally harvesting the succandri. And how do you do that?
So the Synectrons, they're not particularly mobile. I mean, they do move around. The adult stage has wings and they fly. All the instar stages can hop happily, but you pick them just like you would a berry, basically. Yeah. So people go there. The traditional form of collecting them is just to use an empty water bottle or other product, and you just kind of stick them in as you collect them all off the plant very easily. They don't bite. They don't flee. Then you take them in and you wash them twice, which is very important. They have a waxy residue, which is great for reducing predation. One of the things in parasitation, other things that we had expected to find but didn't, but it's not particularly good for people to eat. So you wash it twice. And then you toast it up right away, because if not, it spoils quite quickly. But the whole harvest process is really easy, which is nice, because if it's close to the home, it means that we have a large number of elderly who really enjoy, because you can cook it quite close to the home and it doesn't have bones or many of the other things that can, in mouthfeel, actually prevent consumption later in life. And kids can do it as well, because it doesn't have many of the bones and little pieces that mentally prevent eating food as a child often around the world, as well as it being very, very easy to harvest and cook. So it was something that we saw was quite easy to pick while you're doing something else, but also very easy for kids to even pick on their way home. We had a large number of child producers and consumers who were doing this as their own projects, aside from the rest of their family.
All right, well, great. You have obviously thought about this problem from many different angles, and it's really lovely to see this kind of thoughtful work on a project in a sort of a holistic context of how you do conservation in an area, and this, food security being one component of that. Anything you want to add? Any final comments before we wrap it up?
Just that everything has gone so lovely so far, but there's still so much work to be done. So if there's anybody out there that is working on beans and has questions about these insects, that are working on hemipterans and wants to talk more about this insect, or are working in organizations across Madagascar or in mainland Africa that would like to talk more, that we have a lot of work to do, and are happy to share everything in numerous ways. So we've been training NGOs in Madagascar on how to do that. I've been receiving more messages from people in Madagascar than I ever thought was possible. And we're here and really excited to learn from our colleagues around the world and help them out in any way that we can as well.
Well, that's great. Thanks. I wish you the best of luck with that project. So I also, before we close out, I want to mention that next week, the seminar will be 3 hours later than it is today, 2200 GMT. And we'll be hearing from Aaron Murphy from Arizona State University on decision framework for estimating the cost of marine plastic pollution intervention. Her paper is in press in conservation biology. So that's on October 20th at 2200 GMT. And otherwise, I will stop the recording and say thanks again to Cortni for just a great and inspiring presentation.
Thank you so much for having me.